All right, here we are, Taylor series day 3. This one's going to be focusing on power series with a geometric series. Which some power series look really scary, but if you can realize that they're a geometric series, they actually go pretty well, because we can actually find the sum of a geometric series. Okay, so let's just do a quick little reminder what a geometric series is. Let's see here. Suppose that, and it's right here. So we start with 2 and r is 3. So this would be, so the first term is a 2, and then you're just increasing by multiplying by 3 every time. So 6 plus 18 times that by 3 plus 54 plus, you get the idea, right? So here's a general term for a geometric, depending on what n is, okay? So since this is our geometric, what's really nice is this is the same thing as, what is it, 1. So same thing, 1, if a is 1, so we're starting with 1 plus x multiplied by x squared plus x to the third. So that's like super nice, right? If I'm going to write this as a, this is just x to the n. Sigma form here, this is going to go from n equals 0 x to the n. Okay, so if we can recognize that some of these turn into geometrics, we can actually just use this as the old power series, and we can answer these questions a lot easier. So let's go ahead and go through questions that we've seen before, but now we're going to convert these into geometric series if we can. Now, that doesn't always happen, but if you start to recognize, oh my gosh, it's a geometric series, it'll be fine. Okay. Also important to kind of note here is that the sum of a geometric series is the first term 1 minus r, and that's kind of, if I see anything like in that form, dead giveaway. All right. So find a power series for this right here, centered at x equals 0 for the first 4 non-zero terms in a general term. So what makes this so difficult is that finding the derivative of this is a pain in the butt. It just is. And then you have to find the derivative again and again and again. It's going to just take a long time. So if you realize that, oh my gosh, this is just a geometric series, and I know that a geometric power series looks like this, then I can start to use some of my substitution. So since my sum is 1 over 1 minus x squared, my first term is 1. Okay, I'm just translating from over here. And my r value is x squared. So this is really going to turn into 1 plus x squared plus x to the 4th plus x to the 6th. You get the idea. It's really just doubling up our power here. So get the first 4. So I just did that in the general term, did that. So for what values of x does your series converge? Well, it converges. Remember, it converges as long as r is less than 1. The magnitude of r is less than 1. So since r is x squared, always positive, so not worry about that, as long as that is less than 1. Okay? So if I square root both, so it's going to really look like this. Don't worry about the algebra. Just come on, use your brain for that one. So as long as x is between -1 and 1 here, we are good to go. So for geometric, which is really nice, you do not need to check endpoints. Reason is because if I check the endpoints, it's get 1 over 0. So it's not in the domain anyway. So you don't need to check endpoints for these. Okay, so on your calculator, it says graph that in y1 and y equals 2 is the first 5 terms of the series you found, and we're going to trace each graph to find x equals 1/2 and x equals 2. So all right, let's go ahead and do that. So y1 is going to be this series, which is going to be a fraction of 1 over 1 minus x squared. And y2 to be the first 5 terms. So it's going to be 1 plus x squared plus x to the 4th plus, plus x to the 6th. 5 terms, so obviously the next one's going to be x to the 8th wants me to graph both of them, so zoom 6 that. So first one's in blue. So there it is in blue, and let's see what the heck the first 5 look like here. There you are. Yeah, I think that's really going to be about it. Then again, remember, it's going to be very accurate in the center, which is 0, and less accurate as you get further and further out. So trace x equals 1/2 on both of these. So if you hit x equals, actually, you know what? Yeah, it's fine. X equals 0.5. On blue is 4/3. So on y1, we're going to get 4/3. If I hit up and down, it changes. So I'm going to do the same thing on red. Trace. Okay, sorry. Trace, now choose red, 0.5. For y2, we're going to get 1.332, which is like super duper close. All right. So those are like super close and super accurate. If I do it at x equals 2, so hit trace 2 for blue, I'm going to get negative 1/3. And I'm going to do the same thing for red here. So hit trace, go up to get to red 2. Whoa, baby. Why is that? Sorry, you can't see me writing, but you saw it on the graph. Why are those so too far away? What the heck? Those are so inaccurate. Oh. Because our radius convergence from -1 to 1, and anything outside of that is going to be just totally crazy and totally inaccurate. So make sure you look at the radius convergence for that. That was so neat. All right. So go ahead and find a power series for this centered at 0. Give your first 4 non-zero terms, a general term. So first off, this is not this is not in the form of a sub 1 over 1 plus r. I need this to be a 1. So you're going to divide every single term by 1/4. So I'm going to get f of x is the same thing as 1/4 over 1 plus x over 4. So divide everything by 1/4. So now I can say that my first term is 1/4. My r is x over 4. Okay? So now when I do this, now it needs to be in a minus, mind you, okay? So it's going to be a minus and negative. So this is going to be the same thing as 1 minus a negative x over 4. Okay? This is really supposed to be negative right there. Caught that one. So just kind of be aware of that. All right, so this is going to be of the series. So a1 is 1/4. And I'm going to multiply it by negative x over 4. So it's going to be minus x over 16. Multiply that by again. So it's alternating. X squared over 64 minus x to the third over 256. Get the idea here, right? So we're going to start with 1/4 negative x to the 4th to the n. This is just rewriting my series. So when does it converge? This makes this problem so easy, man. When negative x over 4, the absolute value of that is less than 1. So really, it's just going to be from -1 to x over 4 to 1, absolute value, right? So I'm going to get from -4 to x to 4, which makes these problems so much quicker. Okay. Last one, last little scenario you might run into with this. So find a power series for f of x equals 15 over 2x minus 1, centered at x equals 2. Ooh, it's already different because we're doing everything centered at 0. Give the first 4 non-zero terms in the general term what values of x converge. Okay, so since this is now going to be centered at 0, sorry, usually centered at 0, centered at 2. So we are used to this. 1 over, sorry, a sub 1 over 1 minus r, centered at 0. I want it centered at 2. It's now centered at 2. Okay, So I just need to rewrite this. So this is now centered at 2, which means that I'm going to need to play around with this just a little bit here. So I want to write this so that it becomes an x minus 2. So f of x is going to equal this 15 all over. I want to rewrite this as an x minus 2. So I want to write this as 2x minus 2, right? Now, in order to do that, I need to make sure this matches right here. So if I were to do that, I get 2x minus 4, which means that since that's a minus 4, actually I need to add 5 to that. Right? I need to add 3 to that. So that this matches that right there. Okay? So now I'm going to get 15. Let's do a little bit of a rewrite here. I'm going to make this into a 1, so divide everything by 3. So 2/3 x minus 2. So this is going to be the same thing as 5 over 1 minus negative 2/3 x minus 2. And now this is geometric, where my a sub 1 is 5 and my r is negative 2/3 x minus 2. And now I'm good to go. So this is going to turn into 5 minus, multiply that by, let's see, 10/3 x minus 2. Multiply that again by negative, so plus 29ths, because again, we're multiplying everything by negative 2/3. 29ths, and I want 4. Okay, we can give them 4. Minus negative 40 over 27, x plus 2 to the third. So the general term here is going to be my geometric, which is 5, negative 2/3 x minus 2 to the n. That's my general term. So radius convergence. So f value of this less than 1. So essentially I'm going to get negative 1, 2/3 x minus 2, 1. So multiply that, I'm going to get negative 3/2 x minus 2, 3/2, and then just add 2 on both sides. And I'm going to left with 1/2, it looks like. Yep, 1/2 x, add 2 to that, and I'll get 7/2. All right. So make sure the correct center here, and the center is 2, so we are all good to go. So there you go. So you can do geometric problems centered at 0. It's much easier. Centered at different value here, you can do it. Just takes a little bit of work here to write that as a geometric, and that is going to wrap it up.